trying to prove the area of a circle formula. So we all know how to find the area of a rectangle. We can just find the length and the width and then multiply them and get the area. But in a circle, it's a lot harder because we have all these curved surfaces. So we can use a technique that was used by some ancient mathematicians, and they discovered this technique. So we have our circle here that's cut up into 8 pieces. We can try and rearrange this into something that somewhat resembles a parallelogram or a rectangle. But we still can't find what the area is because of all of these curved surfaces. It would be really difficult to do this. So we can try and split our circle a little bit more. Maybe we can do, let's see, 18 pieces. We can do this, and we'll get another parallelogram, still some curved surfaces, but we're starting to see that the length of this parallelogram is pi r, and the height is somewhat resembling r, or this length is somewhat resembling r. But it's still incomplete. We can't prove that it's the exact value. So we can do more. So let's say if we increase it, maybe 70. So now we see that the height is r, and the length is pi r, but still this length is r. You see this length here? It's not the height that's r, and for a parallelogram, we do the base times the height, so it's still incomplete. And this is what many mathematicians had a problem with. This is not a complete proof. It's a lot of assumptions. So now we can go all the way to the max that this generator will go. Or this simulation, we can go to 1,000. And if we change this into a parallelogram, we see that it is practically looking like the height is r and the length is pi r. And the reason why the length is pi r is because we know the circumference is 2 pi r, and this is half of it. Because if you look at how we make it, maybe I can go down a little bit, or here maybe. You can see that we rearrange it by basically cutting the triangles and putting them intersecting. So the base, this part, plus the height will be equal to 2 pi r, but it's actually just pi r because it's just one side. So that's why. Now we'll go back to 1,000. And still at 1,000, it's still incomplete, but now we can go into a concept of, it's kind of like calculus. We can go into a concept of that. It's that we can make our n, which is the number of slices, we can make it close to infinity or tending to infinity. And what happens is that you can assume that you're getting a perfect parallelogram with a height of r and a base of pi r. And when you multiply these together, like you would for a parallelogram or rectangle, you would get pi r squared, which proves the area of a circle formula. Thank you for watching today's video. I know I haven't posted in a long time because I've been quite busy with schoolwork, but I'll start posting more regularly again. Thank you.